Hey, it's Coach Reeves. Today we're going to talk about compound interest, and then we're going to talk about compounded continually. But right now on compound interest, it's going to be very, very similar to growth and decay. But the one thing that is different is this variable N. That's new. And what does N mean for us? It talks about the number of times per year that it happens. So if you see something that happens 2 times a year, you may see this written as semi-annually in your problem. Or 4 would be quarterly, 12 would be monthly, 52 would be weekly, and 365 would be daily. All right, so if you see these words or these in your problem, then you're going to know that you're going to use these numbers for your N value. Okay, so let's jump into some problems real quick. All right, before we get going, let me do this. Let me clear my calculator out for you. New, no calculator. Let's get rid of some of this stuff here. Okay. All right, so here we go. All right, so we're going to invest $4,993 in a savings account. All right, let me bring our formula over here just to make sure we understand what we're going to use. And I'll try this again. P1 plus R over N raised to the N times T. Okay, there's our formula. All right, let's go back. All right, so we're going to invest in a savings account with a fixed annual interest rate. A fixed annual interest rate of 2%, compounded 4 times, which is quarterly. What will the account balance be after 5 years? So they're asking you for the final amount, the final balance. So they want us to solve for A. So let's invest 4,993, 1 plus our rate. Our rate is 2%, 0.02. Our N, how many times per year? 4 times per year. And we're going to use it again, 4 times, and it turns out that 5 years is our time. And we would multiply that. 4 times 5 is 20. 4 times, we can just go ahead and use this as 20. And that will equal our final amount A. So let's just put this in our calculator and let it do the work for us, okay? So in our calculator, we're going to say 4,993, parentheses, 1 plus 0.02 divided by, we said 4 because it was quarterly, close it, and we're going to raise this power to the 20 because that 4 times 5 is 20. Enter. And this is what we had on our paper, and this is what we get for our answer. Remember, we're dealing with money, so we need 2 decimal places, but we would get $5,516.74. Simple enough. All right, let's try another one. On this problem, we're going to invest in a retirement account with a fixed annual interest rate of 4%, compounded 12 times per year. 12 times, we're going to say it's going to be monthly. How long will it take? Look at that. How long will it take for the account balance to reach $14,051.16? Okay? That means how long will it take? We're going to be looking for T. So we're going to invest $6,322. We're going to 1 plus, it says our rate is 4%. It says compounded 12 times or monthly. But we don't know the time. We don't know how many years it's going to take. This is the unknown. That's the guy we're looking for. And we want our balance to be $14,051.16. So we want to try to solve and try to get T by itself. Okay? Now remember what we've done when we did growth and decay. If we're trying to solve for a variable that's an exponent, we're going to end up converting to log form to solve the problem. Okay? But before we do this, we're going to try to move this to the other side. Divide by 6,322. 6,322. That will cancel. That's going to leave me with 1.04 over 12 raised to the 12t. All right, let's put this in the calculator and get a number for you. 140, 51.16. Let's go new. No. Calculator. 140, 51.16. And we're going to divide by 6322. And we're going to hit enter. And that's going to give me 2.22258. 2.22258. Now, I want to convert this. This is my base, that's my exponent. This is your base. So your log stays your base. Your base stays your base. Excuse me. Whoops. Sorry. Let's come down. Thought I lost it there for a minute, okay? So, we're going to use this as my base, and we're going to say log base 0.04 divided by 12 raised, there's your base. Your base will stay your base, and now you're going to be paired with 2.22258, and that will equal 12t. Now, when we put this into the calculator and get a numeric value, all we're going to do next is divide by 12, and that'll tell you the number of years. Let's move this just a little bit. Okay? All right, go to our calculator, and we're going to say control log, and we're going to say parentheses 1 plus 0.04 divided by 12, and then we're going to cursor over, and then we're going to say 2.22258, if you remember, okay? And we're going to hit enter. 240. And remember what we said, we were going to divide by 12. 240. We're going to divide by 12, and we're going to find out that my time is 20. It's going to take us 20 years to get that balance. Okay? Let's try another one. Okay, so we're going to invest $1,594 in a savings account with a fixed annual interest rate compounded 3 times per year. 3 times per year. After 5 years, the balance reaches a total of $2,365.54. What is the interest rate? We're solving for R. We're looking for the rate. Okay? So, we're going to invest $1,594. 1 plus, I do not know what my R is. Okay? But my N value is 3 times per year. Okay? 3 times per year. 3 times, and we're saying 5 years, so we're going to multiply times 5. And we want to end up with a total of $2,365.54. So if we're going to solve for R, we need to move things to the other side. So we're going to divide by 1,594. Divide by 1,594. This will cancel. Let's put this in our calculator of 2,365.54. Let's go to a new. No. Calculator. 2,365.54 divided by, okay, what did we say? 1,594. Let me check that real quick though. Yep. Enter. And that's going to give me 1.48403. 1.48403 equals 1 plus r over 3 to the 15th, okay? So what I need to do now is, here's my base exponent. Remember how we did this with growth and decay? I want this 15 to disappear, so we're going to raise the power. We're going to raise the power to the reciprocal. And that will cancel that exponent. Raise the power to the reciprocal. That's going to cancel. That's going to leave us with 1 plus r over 3. We'll put this in our calculator. Look what we're going to do. We're going to say raised. We're going to take our answer. Hang on. We're going to raise the power to 1 divided by 15, and we're going to hit enter, and that's going to give us 1.02667. This will give us 1.020667. We're going to subtract 1. We're going to subtract 1.02667 equals r over 3. We're going to multiply both sides times 3. 3's will cancel. When we put this in the calculator, we'll see what happens, okay? We're going to subtract 1 minus 1, and then we're going to multiply times 3. And look what we get, 0.08 or 8%. That's going to give us 8%. Okay, let's keep going. All right, let's try another problem. Oopsies. Okay, we're going to invest a sum of money in a retirement account with a fixed annual rate. It says what amount is the initial. We want to know the initial amount. Okay, so final amount is 2352.16. I do not know my p-value, okay? But we're going to go 1 plus, it says well, our rate is 0.03. Our N will be 52 because it's going to be weekly. 52 times 15 years. Let me speed this up. When you multiply 52 times 15, this will be a total of 780. But what we're going to do is we want to solve for P, so we're going to divide by this entire side of 1 plus 0.03 over 52 raised to the 780 divided by 1 plus 0.03 over 52 raised to the 780. This will cancel and we'll solve for P. All right, 2352.16. 2352.16. Enter. All right. We're going to divide by, divided by, I forgot to divide, by parentheses 1 plus 0.03 divided by 52, close it, raised to the 780. Enter. Yes, this is what we had on our paper, so it's good. And it turns out our initial investment needs to be $1,500. Okay? Here we go. Oh, let's go back here. So we need to be, our initial investment is $1,500. Okay? All right, so this is how we're going to do compound interest. Okay? I'll make another quick video and I'll show you the difference between compound interest and compounded continuously. All right? So see what you can do, and then I'll make another short video for the other part. All right? Hey, let us know if you get stuck. Good luck.